So in this question, we have three naturally occurring isotopes of magnesium, and we're given the percent abundance and the masses that go with them for just two of them, and we need to find the atomic mass of the third one. And so what we're going to do is an equation that looks like this, and that is that the average atomic mass, I'll put the average atomic mass is going to be equal to, we're going to take the percent of the first one, and we're going to multiply that by the atomic mass of the first one, and then we're going to add that to the percentage of the second one and multiply that by the atomic mass of the second one, and then we're going to add that to the percent of the third one and times the atomic mass of the third one. And so because we have three different isotopes, we're doing this three different times, but if we had 4 or 5 or 2, we would just do that however many times. And so what this number right here represents, the average, this is from the periodic table. So I'm going to say this is just from the periodic table. That's what this number right here is from. And so we're not given what the average is in this question right here, but we can go to the periodic table and look it up. And if we go to the periodic table and we look up magnesium, we're going to see something like this. We're going to see that we got a 12 up top, and then we have the Mg here, and then we have something like 24.305. And so this is what it typically looks like on the periodic table. Your periodic table might look a little bit different. You might have the 12 like down here or something like that, but usually the Z number, or the number of protons, is up top, and the average atomic mass is on the bottom. And so this number right here is going to be right in here. And so what we're going to do is we're going to use this equation. So let's put in the 24.305 for the average, and then what I like to do is I like to underline the numbers that go together, and for the percentages and the atomic mass. So for example, we got this percentage here, and that goes with this one here. So what I'm going to do is I'm going to first convert this to a decimal. When I do this equation, these percentages, they have to be decimals, so we're going to put 0.7899, and then we're going to multiply that by this number here, the 23.985,042. Okay, and then we're going to add that to the next one, and this next one, it's this 10% there, and looks like this number there go together. So I'm going to convert that to a decimal. So that's going to be 0.1, and then we're going to multiply that by 24.985837, and then we're going to go ahead and we're going to add that to the next one. Now we don't have the percentage for that next one, but we know there's three isotopes and we have two of them, and the percentages of all of them have to add up to 100%. So what we can do instead is just take 100, and this is a percentage, and subtract that by the first percentage here, this 78.99%, and then we subtract it by this 10%, and then what we get left over is going to be this 11.01%. So this is going to be the percentage. This is the percentage of, I'll put the third one here that we need. And so we're going to take this as a decimal, which would be 0.1101, and then we're going to multiply it by an x, because we don't know what the mass is that goes with this. So we'll put that number, and we'll put an x right here, and then we'll solve this equation for x. And so when we multiply these two numbers together and multiply these two numbers together, and then we'll go ahead and divide this on both sides, we're going to get, this is going to be 2.863, and that's going to equal 0.1101 times x. And what I did to basically get this was I took these numbers, multiplied them, and then I added these two numbers, multiplied those, and then subtracted on both sides, and then took this number there, subtracted it from what I got there, and then I have this thing left over that's going to be right in here. And then what we'll do is divide by 0.1101 on both sides, and then we're going to get, this is going to be x, it's going to be equal to 25.982, and that's going to be atomic mass units. So this would be the atomic mass of that third one.